open this thing up. All right. So in our class, we had already, you know, of course, beat you up with the 4-stroke cycle. And this particular presentation that I put together is on our school engines, which are these Intech 206 engines. But it shows you a good step-by-step process of how to take something apart. In addition, I have one for a flathead engine that we'll go through here in a minute. And I'm gonna just hit the highlights. This presentation is available for you on Canvas. So if you want to go through it step by step, you can, and it does match this engine. However, all these Intech series Briggs engines, these whether it's 206 cc's or 300 cc's, they will all basically follow these same steps. All right, so with that, let's look at some tools here. Remember that you can get the manual here. You can get this guy right here, right off of the power portal. Some of this stuff isn't necessarily needed if you're only taking the engine apart, but some of the things, if you're putting it together, like you're gonna need some type of a torque wrench. That's a piston ring compressor, you would need that if you're reassembling your engine. This looks kind of weird. That's actually just a microfiche. It's a way that they set the gap between the flywheel and the ignition coil. To take it apart, you really need the manual and you need these hand tools here. And you might also need that strap wrench, but there's a trick on that as well. So let's dive in. Of course, if you were going to build your engine and make it run, at the bare minimum, you would need some gaskets. So this one right here, this is your case gasket, and this is your head gasket right here. This is for the exhaust, that's for the intake. What's great about a small engine is you could probably get all of those gaskets for less than $30, right? Whereas if you were building a car engine, you'd spend over $100 just in gaskets. All right. So systematic approach is a big deal. When you're taking something apart, I want to underline that this is not a race, right? Be methodical how you take stuff apart. Your disassembly is your final diagnosis on what happened to this engine. Put fasteners back with removed assemblies or loosely back in their holes so you don't lose your parts and you keep stuff organized and you see how stuff goes together. So if you were taking apart an engine, the first thing you'd want to do is shut off your fuel, disconnect your spark plug wire. Obviously, you'd want the engine cooled off so you're not burning your hands or anything. You're going to remove the air cleaner cover and filter. Now, I'm going to pause right here real quick and give you a couple of notes here. It says foam pre-cleaner washable if necessary. A lot of these engines will have a foam pre-cleaner built into that cover, or basically attached to that cover first, ahead of the paper air filter. You can clean the foam pre-cleaner. If you have a paper filter, that you would want to replace, right? So the other thing I'm going to do is I'm going to look at this housing underneath the air cleaner cover. I'm going to wipe my finger around on here and see if there's any dirt coming off of there and sticking to my finger. The reason is, if there's dirt underneath the air filter assembly, that means that dirt was getting through the air filter and it was sucking on your engine, and that will destroy a good engine in a short period of time. So if you have a compression issue, if you have worn piston rings, dirt ingestion, they call it, basically the engine drawing in dirt, is an easy way for that to happen. Super common because we operate a lot of these engines in pretty dirty, extreme environments. So always check underneath your air filter to see if the engine has been ingesting dirt, sucking in dirt. So I'm going to write in here, check for dirt. Okay. Remove the air cleaner backing plate, disconnect the breather tube. And I want to talk about this breather tube. Here's a little gasket. If this gasket was damaged, that would be a way for dirt to get in the engine. Also, this little breather connects to the valve cover, and it basically keeps the crankcase clean. It pulls air through the inside of the engine, and sometimes that'll get disconnected, and that's how dirt gets into the engine. So you want to check all those things. Now, before I get too far ahead, let me make sure that I open up the chat. I'm going to stick the chat right below my face here. So if you have a question, you can either just, you turn on your microphone and tell me the question, or you can put it on the chat. I know some folks, and I'm a little bit this way myself, don't necessarily like the sound of their voice on the video. So you're welcome to do that. While I'm taking a moment to pause, does anybody have any questions? I have a question for you. Can you guys see my screen right now? Is it looking okay? I have removed the speed control panel. Can you guys see that? You could respond with the chat. Looking good. Okay, thank you.
Looks good from my end. So. Perfect.
Thank you, guys. You're never 100% sure, and I apologize for starting late. I got to the college here. You can see I got this cool backdrop with our Chrysler poster, but it took me much longer to get the internet working here at the school, and man, it's a ghost town. It's pretty locked down here, so it was difficult getting this set up. All right, so the speed control panel, I want to talk about this for a minute. Because it kind of confuses people. Heck, it even confused me a little bit at first. How many of you guys, you've probably seen this control on a small engine where you got the little rabbit over here, you got the turtle over there. So of course this is fast and the turtle is slow, right? What you are adjusting by moving this back and forth is basically tension on the governor spring. So when I move it to fast, this lever pulls the governor spring and puts more tension on that to get the engine to rev up. When I move it down, it does the opposite. It lessens tension, and so you have less pull from the governor spring. And if I go on this particular engine, if I go all the way, you see a little stop sign right there. If I go to stop, it'll actually kill the spark. I've had lots of students and customers and even colleagues, and these are people who teach auto shop and stuff, and they're like, oh, I don't have any spark, and they have this assembly misadjusted, and it's killing the spark right there at the throttle control. So if you ever have an engine that's not starting and you don't have any spark, make sure that the kill mechanism is not grounding out your spark. But long story short on this type of an engine, you are not controlled directly of the throttle. It's not like your car where you might step on your gas pedal and there's a cable that connects your gas pedal or accelerator pedal directly to the carburetor or throttle body. That's not the case. You're controlling, on this engine, you're controlling the governor system, and then that's controlling the speed of the engine by controlling the carburetor. All right. So it says, hey, throttle lever must be centered. If you don't center it, it gets caught when you try to take it off. It's a pain. All right, take the gas tank off. It comes off as an assembly, a couple 10 millimeters. And a lot of the disassembly is just taking apart a lot of these externals and kind of laying those out. I recommend that you use your cell phone, take lots of pictures as you go along, right? We have cameras in our pockets now. Take pictures as you go, so it's easy to figure out how stuff went. All right, so you're going to take off the blower housing. This is also called the finger guard. So if you did the activity where you looked up information about your engine and it talked about cleaning out the air vents, you know, cleaning off the finger guard, this basically, these little slats keep your fingers from sticking in there and getting all chewed up in the fan. This is the finger guard. If you're operating this engine in a real dusty, dirty environment, a bunch of dirt will stick to that thing and leaves. And so you're supposed to wipe it off and blow this thing off if you can. So, okay. And then we're going to remove the muffler. And of course you want the engine cooled down. You usually have to take off, this is a heat shield. You'd have to take off the heat shield first. Then you can actually get to the bolts underneath it. A lot of these mufflers, the majority of them are going to have some type of a spark arrestor mechanism. And that keeps any sparks or flames from exiting out the exhaust and causing a fire. These mufflers actually over time, especially on two-strokes, they'll get clogged up with carbon and soot, and that could be a cause of low performance. So you could have a restricted exhaust system, especially on a two-stroke, because they naturally make smoke as they're running, and it's the spark arrestor mechanism in the muffler getting all clogged up. Okay, so that's just a little tip there. Check your exhaust. So we got the shield off. Now we can get to these two bolts on here. This is a gasket. If you were going to run the engine, you would have to replace that gasket. It rips every time you try to take this apart. Take off the carburetor. Notice that there's a little plastic spacer that keeps heat from the carburetor, and that means that there's gaskets on both sides of the spacer, and the spacer only fits on correctly one way, but I have had people get it mixed up. So, you know, pay attention to how it goes. And then underneath the gas tank, now that you've taken the gas tank off, there's this plate, and this is essentially the governor plate. It has your governor lever. This was that throttle control right here that you slid back and forth. The spark plug, grounding wire comes into play right here. And I have on here, lift the complete assembly off. What I recommend you do is don't take apart stuff that you don't need to take apart. So it's going to be a lot more work for me if I take this off of here and I take that off of there and I take the spring off and I toss it, and this is the throttle link. If I disconnect that, that's going to be, you know, 45 minutes of frustration trying to get all that stuff back together. If I don't need to take that apart, don't take it apart. This assembly has 4 or 5 bolt holes. I'm going to circle these 4. If I take off those 4 bolts, I can lift the whole thing off as an assembly and keep it together. That's what I recommend you do whenever possible, to not create more work for yourself and not create work in having to do a bunch of adjustments getting it together or opening up yourself for losing parts. So again, don't take apart stuff you don't need to. Whenever you can remove something as a complete assembly, I recommend that you do just that. There's a heat shield that goes on the side of the cylinder that you would take off. Notice some of these are really, really small fasteners. It says 7mm socket. This particular, it's got one little tiny bolt that holds it on there. I've had a lot of students strip that thing out. If you look at the torque specs for these engines, they are all in inch-pounds. So that means that it doesn't take very much to strip them out. They don't have a lot of torque values. Your highest torque bolts on the engine are somewhere around 200 inch-pounds. Most stuff is around 70, 80, 90 inch-pounds. So if we do on the math on that, that's well below 10 foot-pounds. It's not very much torque. So be careful with all your bolts. It's very easy to strip stuff out. So the valve cover, this is an overhead valve engine, right? You see OHV on there. That little hole in the side, that's where that black plastic hose went to the breather. So that's your crankcase breather. Screws have different lengths and thread pitches, so you got to remember their location. What I would do is I would take the valve cover off, I would take these bolts out, and then I would loosely thread each bolt back into the head of the engine so they're in the right spots. So here is the valve cover removed, and you can see the valve cover gasket. Sometimes you can get away without having to replace a valve cover gasket, but like this one in the picture, you can see it looks like it might have a little tear right there. It'd be smart to replace it. But what I would do is I would put those bolts back in these holes, loosely thread them in because they're not going to be in my way, and then I haven't mixed up their order. Okay, so now I have to just disassemble the valve train, and I'm going to loosen my rocker arms. This is how you do a valve adjustment, by the way. You can see he's got an Allen wrench here. He's got a 5/8 wrench there. If you're putting your engine back together, this is pretty critical adjustment to get the engine to run correctly and not fail. Here we're just taking it apart. So we're just gonna loosen these guys. Once we loosen them, we can then pop these rocker arms to the side, pull out the push rod tubes, and take this assembly apart relatively easily. Again, don't take stuff apart that you don't need to take apart, all right? Here we're going to remove the spark plug. I've already recommended that you guys in other videos, I think our compression test video, to use a spark plug socket so you don't destroy the spark plug. I love how Briggs & Stratton puts their logo on everything, even the spark plug there. So this is a critical part of the assembly. It says use a 10mm socket, remove the cylinder head, right? Well, what we want to do here is remove this head in such a way that we don't damage it or warp it. So each one of these bolts on this particular engine, I want to say, is torqued down to 220 inch-pounds. It's the highest, one of the highest torque bolts on the whole engine. So if I just loosened him, these other three are still pulling it down. I could warp this thing taking it apart. So what you want to do is crack this guy loose and then crack this guy loose and just loosen each one like 1/8 of a turn. Then go back through and do this in stages. In fact, what I would do is I'd go across. So I'd go number 1, number 2, number 3, 4, and I just work it loose in stages. Once you get all the bolts out, once they're all out laying on your workbench, this cylinder head might still be stuck to the engine block because just the stiction of the head gasket. And what you might have to do is take a rubber mallet or a soft plastic covered dead blow hammer and just lightly tap on the head to get it to break loose. And then it should come right off of there. All right, so now we got 2 little bolts right here to remove the ignition coil. This coil is set up really, really close to the flywheel, and that's something that you use a thin, somewhere around a 20 to 30 thousandths thickness piece of cardstock, like a couple 3x5 cards works pretty well. Briggs likes to use a microfiche file, but that's how they set that gap. Anyway, so you're going to take that off of there, take the ignition coil off. And this right here is where the strap wrench comes in. Notice how they're using the strap wrench. It's got this curved end, but that's actually away from the engine. I'm loosing it, so this guy's going counterclockwise, and this guy kind of jams in there, and with the action of the strap, it prevents the flywheel from turning. Now, that's the best and safest way to remove this flywheel nut if you only have hand tools. This bolt is on here with somewhere between 50 to maybe 65 foot-pounds of force. So there's a lot of torque on that. Now, if you have air tools or electric impact tools, you could hold that thing with your hand and zap it off with the gun, okay? But if you don't have impact tools that hit really quickly, you're gonna need a strap wrench or something to get that off of there. Now, this nut is screwed onto the end of the crankshaft. So let me fast forward a couple slides and let's look at the crankshaft here. See these threads right here? That nut is threaded on those threads. So I know some of you are thinking, well, what if I had something bolted on this end? Couldn't I just hold this bolt with a ratchet or something and loosen that nut? You could, but in the process, you could also twist your crankshaft. So the danger of that is that you could damage the crankshaft and twist it doing that, especially on a two-stroke engine. This is a four-stroke engine. This crankshaft is all one piece, but on a two-stroke engine, this is three different pieces. So if this was a two-stroke, this is one piece, this is one piece, and that's one piece, and then the counterweights are pieces. So it's you know, they call it a three-piece crank, and you have to press it together and get everything in phase. It's really easy to slip or spin a two-stroke crank. So that's why we do it the way that we do. Now, does anybody know a different way I could get this bolt loose if I didn't have a strap wrench and I didn't want to, you know, hold the other side of the crankshaft so I don't damage the crank? Is there another way I could do this, get that bolt loose? I have a question here. Why is a two-stroke crankshaft made in multiple pieces? That is a good, that's a good question. A two-stroke, and I wish I had some pieces here, but I do have some pieces. Hang on. Okay, so let me do this. Instead of doing a share, I'm going to stop the screen share, and you guys should just see. Okay, you should see me, and hopefully my image is big now. You can see what I'm holding up here. On a two-stroke engine, the rod bearing is not just a plain flat bearing like this four-stroke little piston and rod is. There's going to be a needle bearing in there, right? If you've done that still training on the different bearings, you'll notice that on two-stroke engines, they use a lot of roller bearings and needle bearings. The reason two-stroke engines use better bearings is they have less lubrication for their engine, right? It doesn't have a quart of oil or 2 quarts of oil in it. You're mixing a little bit of oil with the fuel. So your lubrication, for all intents and purposes, it stinks. So they have to make the bearings better. Well, if I have a roller bearing in here, how am I going to replace that? Because it can't come apart half and half like this one can. Well, that means I have to press the crankshaft apart to replace that roller bearing. And that's why two-stroke engines use a three-piece crank. Now, related to that, what I'm going to do is we'll get a new screen share going. But this time, I'm going to get the internet going, and hopefully I'll be able to pull an image up really quickly to there we go. My internet's thinking about it. Okay. And now I have to get this screen share going correct. So I'm going to go to screen. Okay. Okay. My computer's being slow. Sorry, guys. Let's try this again. Screen share. New tab. Okay. Oop. Try this again. Screen share. Google tab. Okay. Hey, there we go, hot rods. So hopefully right now you guys can see my, my screen, and I have motorsport.com opened up. And what you see is a picture of a two-stroke engine crankshaft. And remember how I said there are multiple pieces? So a three-piece crank. So I have this piece, then I have a tube that presses through here to the other side, and then the other side of the crank. And the question was, why is a two-stroke crankshaft going to be a three-piece crankshaft or more sometimes? Because there is a bearing like this between the connecting rod and the crankshaft here. And the only way to change that style of needle bearing would be to press this all apart. What I recommend you do, if you're doing this type of stuff at home, it is very, very tricky to press apart a two-stroke crankshaft and put it back together. Even more tricky to do a multiple cylinder two-stroke engine. Like a lot of your jet skis, they were twins, right? So they have two cylinders in their two strokes. Your Banshee quads were, you know, 250, 350, two strokes. They had two cylinders there. Some engines were triples. They had three cylinders. Those are super tricky to press together. Just pressing a single crankshaft assembly apart and back together is super tricky. You have to do it with good press, fixtures, V-blocks, put on the lathe, dial indicators. It's a frustrating experience. If you have a two-stroke engine and this bearing down inside here is worn out, like the rod bearing shot, what I would recommend you do is you buy a kit like this one. This is from Hot Rods, and there's other manufacturers, but you can get an assembly where the crankshaft comes shipped. It's already all put together, and you put it in your engine. This little bearing actually goes right here in the small end of the rod. It's your wrist pin bearing. So again, we have a roller bearing or needle bearing here. We have a needle bearing there. Both your main bearings are roller type bearings. So two-stroke engines, better bearings because they have a lot less lubrication. The lubrication stinks, so they make up with it with better bearings. They're also pulling a lot more RPM, and that's why you have a three-piece crankshaft in a two-stroke engine. And so you can see, when you look at this, you can see why if I were loosening this bolt, it'd be really easy to spin this because it's only pressed together. You can get it out of phase. All right. So with that, what I'm going to do is I will change my share, or in fact, I'm going to stop the share of the screen. And so hopefully that answered your question there. My question for you, if you guys remember, I was asking how could if I put this presentation back up, I was asking you guys, how could I loosen, if I get to this picture of this, how could I loosen this bolt to remove the flywheel? The easiest way would be with the strap wrench here. I'm going to keep the screen like this just so I can scroll around real quick. But there is another way. Before I take my cylinder head off, so let me get a picture of the cylinder head here. All right. Before I take the cylinder head off, I could actually put something in the combustion chamber through the spark plug hole. They actually make what they call a piston stop, where you would take the spark plug out, thread this tool in through the piston, and the piston will come up and hit that tool. The other thing that you could do is you could put some rope in there. Basically, if I filled up the space on top of the cylinder with something, I kind of like the rope because it's soft. Then what would happen is the piston would move up and it would hit that material and it couldn't roll over and it would kind of hold it. And I could use that to keep the engine from turning. Again, I wouldn't recommend that on a two-stroke, but that works pretty good on a four-stroke engine if you don't have a strap wrench. But I'll tell you, this strap wrench, super handy tool to have. If you don't have one, it's worth your time getting one. So let me get this thing going again. So the crankcase cover. we have all these bolts. This is probably your other critical thing here. This one and then your connecting rod ultimately are your three critical setups here. But again, loosen these in a series. So crack that one loose, 1, 2, we'll go 3, 4, 5, 6. Loosen these in stages, tighten them in a torque pattern again in stages if you're going back together. I've seen multiple engines fail, even engines at the racetrack, because this surface was not flat and these bolts weren't torqued down right, and the oil leaks out of the bottom, the engine loses oil, and then it seizes up. Okay, so pretty important. This case cover is really a critical area. And I want to say the torque spec is between 90 to 100 inch-pounds. So it's not a lot of torque, but it's super critical that it's loosened smoothly and taken off. And then when you're on assembly that you do it again in stages. All right. Camshaft. This is something I've been wanting to show you. You can see the cam is made out of plastic. And it's a special hard plastic, a Devron. Anyways, it's a special hard plastic. But the reason they do that is the plastic's light, it's cheap, and it's, you know, strong enough for the job that they're trying to do. I wanted to point out this thing right here. That is your compression release mechanism. It's an automatic compression release. So when the engine is turning slowly, that thing's bleeding off compression. When the engine turns over 200-300 RPM, that little thing, centrifugal force, really centripetal force, moves it, and then it moves out of the way, and it's no longer blowing off compression, and the engine runs stronger. That is purely there to make it easier for you to pull start it with your hand. And that is the reason why we only will get, you know, maybe 80-90 PSI on a compression test on one of these engines, because that thing's purposely blowing off some compression to make the engine easy to turn. If your valves are not adjusted right, this will not work correctly, and you're likely to try to pull over the engine and it rips the cord right out of your hand because you have too much compression. All right, so now we're getting down to the nitty gritty, and we're removing the piston from the crankshaft. I wanted to point out a couple things. This has a little dipper that screws to the bottom of the piston. It's splash lubrication. That thing actually goes into the oil, grabs some oil, throws it up around there. I've had several students go to put their engines back together. They forget this part, and the engine seizes within 30 seconds because there's nothing there spinning around the oil. The wrist pin clips on the side of the piston. Those clips are super important. If you take your engine apart and then you're going to put it back together and run it, you have to buy a new clip, because once you get them out, they get kind of mangled. If you try to reuse them, they never seem to want to stay in there. They fly out and it's catastrophic failure. So always new wrist pin clips if you're going to run your engine. Those are a little tricky to get out. Needle nose pliers, you kind of spin it and you can get them out of there. We talked about the crankshaft. Here's a bare block once it's all cleaned out. You know, one thing I didn't say, but obviously before we started taking the engine apart, we would have loosened the drain plug and drained out all the oil that we could from the engine, right? You notice these engines have a drain plug on each side to allow different mounting configurations and stuff, but we would have drained out all the oil we could when we started. Once you get it all apart, there's still going to be a film of oil everywhere. You're going to have to wipe that out and clean it up and check these surfaces to make sure that they're flat. Look for broken fasteners, any signs of damage. You know, there's a fair amount of cleanup, especially if you're going to be running the engine again. It has to be surgically clean going back together. All right. And then you would, you know, start reassembly with, you know, new parts maybe. I do want to point out a couple things on reassembly. We're not going to get through all of reassembly today because I want to show you some other engine types, but if you're doing reassembly, you really need some piston ring compressors like you have right here. So you need a ring compressor to get that guy in there, and you'll notice that it has an arrow on the piston. The arrow faces the flywheel. All right, well, you two-stroke heads are probably going, well, what about on a two-stroke? On a two-stroke engine, there's an arrow, and the arrow faces the exhaust port on a two-stroke. So arrow to the flywheel, I'm going to put four-stroke. Arrow to exhaust port on two-stroke. Okay. Torquing critical fasteners, 100 inch-pounds on those rod bolts, super critical. And then I wanted to stop right here. When you're putting the engine back together and you want it to run, you have to time the crankshaft to the camshaft. That's super critical. And how do you do that? There's marks on these. So there's, and I know it's kind of hard to see on here, but there's a mark on the camshaft and a mark on the crankshaft. So I have to get this little dot to line up with that little dot. When I go to put it together, I have to line those two things up so that the camshaft is opening the valves at the right time in the four-stroke cycle based upon what the piston's doing inside the engine. So you have to set your cam timing, is what we call this. Cam timing. Super important. The engine will not run, and some engines could even suck valves if you didn't set the cam timing correctly. Okay, and notice that their torque sequence, all that stuff. All right, so what I want to do right now is change things up just for a bit. Speaking about the cam timing, I wanted to show you a couple different setups and some different engine parts here as we kind of wrap this up. So I'm going to stop this share, and I'm going to change my camera here. There we go. I'm changing the camera, and I'm going to put it down on some engine parts here. How about this one here first? Okay, let's see how this is gonna work. Sorry for the shaky camera work, guys. What I'm gonna do is I will put something on my camera to keep him held in place. I'm going to put just a piece of paper down so I have kind of a more blank thing. So here I have a cylinder head. This is off a Honda CR82 stroke. 4 bolts and this head would come off. This head is water cooled. So you can see it has water inlet and outlet passages, those passages going around the cylinder head. And of course, a 2-stroke engine doesn't have valves, so I'm taking out the spark plug. You can see the nice combustion chamber surface right there. Just wanted to show you kind of a different design. So that's the cylinder head off of a pretty high performance 2-stroke engine. The neat thing about 2-strokes is overall they are less complicated and they do not have valves in the engine. All right. Speaking of valves, I want to show you guys this engine assembly right here. This is a Honda, and I'm thinking, well, I can't really see anything. Let me flip this guy over so now we can actually see the valves. This engine, this is off of a Honda small, this is a lawnmower engine vertical shaft. This thing is not just overhead valve. Here's the spark plug hole, right? I'll thread a spark plug in there. So here's the spark plug hole. Here's the cylinder head. These engines are great engines. They're super reliable. They're not the most fun to work on. There's no gaskets. Everything's put together with RTV sealers. And what you'll notice is that the cylinder here and the head are all one piece. So you cannot actually remove the cylinder head from the cylinder. It's all one component. The other interesting thing is that it's not only overhead valve, right? Because the valves are up here in the head. It's overhead cam. So this is my camshaft sprocket. And if I look at this guy, if I flip him over to set cam timing, and now that I got the spark plug in, I can't turn it, you can hear it building compression. See that little line there? That line there? To set the cam timing on this, you have to have those two lines flat with the engine. And then you have to have the piston at top dead center. So if I look down here, here is the timing belt, and it is bathed in oil, and it's fine with that. So here's the timing belt. And if I notice that this parting line on the connecting rod, it's pointing up, straight up. So that's how I properly time this engine, is I get this guy pointing straight up, in line with that. The lines are up on the head. So this is an overhead camshaft, small engine off of a lawnmower. Again, it doesn't have a gasket. This would be all RTV silicone sealers. They're really great engines. They're powerful. They run clean. They're reliable. Kind of a pain to work on, honestly. They're not super pleasant. All these sharp edges tend to cut up your hands, but that's just a different way to do it. What if I wanted to adjust these valves? I still do need to periodically do that. I take off the valve cover by removing those 4 bolts. Again, you can see the remnants of sealer. And then this is my valve adjustment right here. So see, that one's way out. What I would do is then I could turn this guy and tighten it up with the lock nut to get that valve adjustment correct. So that's an overhead camshaft Honda small engine. Okay, speaking of 4-stroke cycle engines, this is a vertical shaft engine. This would be the bottom of it where it bolts to the lawnmower. You see that little divot right there? That's the kind of the bottom of the oil sump. That's where the oil slinger goes. This is, again, why you can't run a vertical shaft engine in a horizontal configuration, because the oil is made to drain and end up right here. What if I want to change the oil on this engine? Well, it does have a drain part on the bottom, and then how I filled the engine with oil is right here. It doesn't have a lot of oil that goes in this. It's maybe only about halfway up here, but that's where the oil would sit inside this engine. The oil slinger goes right there, and I'll show you one of those in just a minute. I got 2 more parts. Here is a cylinder off of a small 2-stroke engine. I'll flip this around so you can see it a little bit better. This would be off of a piston port 2-stroke engine. How do I know it's piston port? Because the ports are going in the sides of the cylinder, not down in the crankcase. So here's my exhaust port. You can see it's dirty in there. Here is my intake port. So it's a piston port 2-stroke. Again, the cylinder head is part of the cylinder on this guy. You can see that it's not 2 separate pieces. I can thread my spark plug right on the top. 2 bolts hold this whole assembly down, right here and right here. What I wanted to show you guys on 2-stroke engines, yeah, there's no valves and stuff. There's these ports. These are the transfer ports on the sides. So when it draws an air-fuel mixture on the bottom down in the crankcase, how does it get the air-fuel mixture above the piston? When the piston moves down, it squeezes the air-fuel mixture, and that forces it up through these transfer ports to the top of the cylinder. So these are called open transfer ports because they're not just little windows, they're whole channels that are cut in there. Notice that they're angled away from the exhaust to try to keep fresh air-fuel mixture from just flowing right out the exhaust. A great way to measure the condition of a 2-stroke engine is just to take off the exhaust port, or take off the exhaust muffler, take off the carburetor, and look through the exhaust port and intake ports, and you can see the piston and cylinder, or you can see the piston and ring in there, and kind of evaluate how much wear is on those by doing a visual inspection. All right, so cylinder off a 2-stroke. Last part, last component I have to share with you is a small engine carburetor. I'll flip them around so it's easy to see. Okay, so here's what I want to recommend for you guys. In the class, I want you to take apart a 2-stroke, take apart a 4-stroke, and take apart a carburetor. Now, normally in class, we start on the engine and then move to carburetors. But if you've never taken anything apart before, taking apart a whole engine, that might be, you know, a little complicated right out of the bat. So if you want to, start with the carburetor. It's pretty simple. I'm going to take this one apart. This is my choke valve right here. This is how I put the choke on to enrichen it up the mixture. But basically, there's going to be a nut on the bottom of the carburetor. Of course, I didn't bring any tools, but okay. So there's a nut on the bottom of the carburetor. This also serves as the main jet on this carburetor. Here's my float bowl. Here's my float assembly. And see, what I'm trying to show you is that, you know, there's not a lot to this carburetor in this engine. And so if you want to take apart something kind of easy at first, by all means, do so. I'm trying to get my plan's backfiring because I didn't bring tools with me, but so I'm trying to be kind of ingenious here. All right, so there's the float pin. I'm going to take the float. There's my needle, the seat. All right, and let me show you how I would, how I want you to label stuff. So let's say you're doing the carburetor activity, right? Get yourself some Post-it notes, some 3x5 cards. Put those guys down and just lay it out on a piece of paper. Of course, my Sharpie pen's dying too. All right, so here is my bowl nut slash main metering jet on this engine. So, you know, you'd set this all up, take some pictures of it. You could take video of it, I guess, if you wanted to. Pictures would probably be easier. So if you want to start with your carburetor and the disassembly on that, that would be fine. If you're doing, if you're taking apart your engine, as you start taking things apart, label stuff the same way. So if this is my, you know, my piston, and especially if this thing doesn't have to go back together, you could take the piston off the connecting rod and not worry about having to replace those clips. All right, set up your cards, set up your photos. So that's what your disassembly activities, that's what you're going to be submitting, is basically pictures with cards where you labeled stuff, right? All right, so now we're getting short on time. So what I'm going to do now is I got one last thing to share with you, and that is this presentation. We are not going to, we're not going to share the whole thing. And I'm going to change the camera back. Oops. Okay, here I am. All right. So we are going to, I'm going to close that one. All right. So this presentation, I built it for our flathead engines. And what I want to do is just skip to some stuff. So this would be an example right here of a vertical shaft flathead engine. So here's a vertical shaft flathead engine right there. There's that little bulge on the bottom. That's for the oil sump. If you're taking one of these flatheads apart where the valve, see this valve is in the engine block, right? It's not in the cylinder head. How do I get the valves out of there? To take it apart, all I need is a screwdriver. But to get it back together, I'm going to need the valve spring compressor. Okay, so how do you do that? Well, you get the engine at top dead center. Both valves are closed here, right? So both valves are closed. Not intake valve open, not the exhaust valve open. Both valves are closed. And the valve springs are in a little valve spring box. This is on the side of the engine. There's a little metal cover held in with these 2 bolts on the side. You'll notice that there's a couple little notches in the valve spring retainers. What you have to do is spin it so that these notches are out. Now, how do the valve spring retainers work? They have a big hole and a little hole here, and the little hole is set up so that's what holds the retainer on the valve spring. We basically have to shove this guy over so that the big hole lines up and it'll slip off. So I move the notches out. I take my screwdriver in there and I just lift it up and to the side, and boom, it'll pop right down, and then I can pull the valve out of the engine. I do have to be careful to make sure that there's no burrs on the valve tip so I don't score the valve guide, but the thing will just lift out at that point and I can take the retainer out. And you can see how I said that there's a big hole and a little hole. We're trying to push it to the side to get it in the big hole. So all I need to take it apart is a flathead screwdriver. If I were going, and then here's a good example of how do you label stuff. That's what I want you guys to do on your projects as you're labeling components. You can see the notches on the valve spring retainers, right? All right, how do you put it back together? Well, the dampening coils to the top of the chamber. Basically, you have to use one of these little valve spring compressors, compress the valve spring, line it up with the notch, get it set up in there, and then put it in the engine, stick the valve in, release the valve spring compressor. So to put it together, you absolutely have to have one of these valve spring compressors. If some of you guys are trying to build a working, running flathead engine, you know, you're going to need one of these tools. They're not very expensive. You don't necessarily need it for the class because remember, I'm only asking you to take one apart. But if you want to build one and want it to run, you're going to need that tool. It's really not, you know, I'll say it's darn near impossible to get that together without that tool. Okay. The last thing I promised you was a picture of that oil slinger. And I realized that this presentation, guess what? It didn't have that. So I got to do one more presentation, and that is the other half of this thing. So remember, this is for a vertical shaft flathead engine. This is a vertical shaft flathead, right? That's overhead valve. That's a horizontal shaft. But vertical shaft engines, whether it's this one or this one, is going to have some type of little oil slinger if it's a splash lubrication. So what I'm going to do here, I'm going to make this a little bigger so I can see it just a little bit better. And I want to show you the oil slinger. Now remember before we talked about camshaft timing? All right. Here are the marks on this engine. Crankshaft, camshaft, right? So here's my crankshaft and my camshaft. And I'm getting the 2 dots lined up together, so I've properly timed the camshaft. But you might be wondering, well, what's this weird plastic thing with these little paddles on there? That is your oil slinger. So again, timing marks. So this guy basically meshes with the camshaft gear, and he kind of floats around on there, but he ends up sitting in that little sump area of the bottom of the crankcase that I showed you guys earlier. And as the camshaft's spinning, right, the crankshaft spins, that turns the camshaft turns this little oil slinger. He's sitting in the bottom of the engine like this, right? This is the bottom. He's sitting down in this little sump in the bottom, and he grabs some oil and he throws it around. So why does this engine, why does the bottom of it, now mine's an old white one instead of a black one, but why does it have this little bulge right here? Because that's where the oil slinger right here lies. So again, this isn't going to work right if I try to run this thing horizontally. It's not going to work. So that oil slinger is important for that splash lubrication system to work correctly. And he just kind of floats in there and finds his home in that little recess in the engine. If the oil level gets too low, these plastic paddles won't have any oil to scoop up and throw around, and the engine will seize. All right, so we covered some important stuff today, from oil slingers to camshaft timing to disassembly procedures and the kind of methodology that you do taking apart an engine, and some tips for removing the flywheel nut. So covered quite a bit of stuff. What I would like to do is use this opportunity to have you guys ask some questions. So I'm going to stop that screen share. Any questions, anybody, that I could answer? And I'll put up the whiteboard here so I could draw something out if we needed to. So, and I need to get that chat back up. There we go. All right. So, any questions related to any of this stuff, engine disassembly, the videos, anything like that? Does anybody have some stuff that they want to ask?
I have a quick question.
Yeah.
I've never taken anything apart before.
Okay.
So you recommend doing the carburetor part first?
Yeah, I would say if you haven't taken apart anything before, and so you know, it's all about your comfort level. If you haven't taken anything apart before, you're not super comfortable, do the carburetor first, because there's just less stuff there, right?
Okay.
And that way you're not overwhelmed with stuff. Take that apart. So maybe watch some of the carburetor videos on like the Power Portal, so you got an idea of what's going on inside there.
Right, because I don't.
And then take the carburetor apart. You know, you'll need like a Phillips screwdriver, a flathead screwdriver, and you know, maybe a combination wrench or an adjustable wrench. There's not generally a lot of stuff to a carburetor.
Okay.
For your
Is that in a different module? That assignment?
That would be module, I want to say module 4. So let me so what I'll do is I'm going to get a new share going with the internet share. All right. And we will log into Canvas, hopefully. My Canvas will look slightly different than yours, but that's okay. Get this going here. Let's see, my things are doing weird stuff. All right, there we go. Okay. Okay, so if I go to modules, which I was trying to do, module 1, module 2 is the compression, and then module 3 is fuel systems and carburetors. So it'd be module 3. I have a presentation here on fuel systems that matches the book. So it's a little dry, but the biggest thing I like about these presentations is it's got the pictures, right? And I'm, you know, pictures worth 1,000 words, and this thing's got some good pictures that shows you the inside of a carburetor once it gets past all the physics type information. So it kind of shows you a setup right there, talks about how it works. So we have that. Let me go back from here. We also have the Briggs & Stratton carb systems. So I would go through and I'd start watching those videos on Briggs, and you know, it'll kind of show you the parts and pieces. And then just like the carburetor that I took apart today, it's pretty simple. So start with that, and then we'll go from there. And again, if you have questions or, you know, like, be sure to talk to me. The one thing I will say on the carburetor, if you've had an engine where it's been sitting around a long time, or it's likely the gas has gone bad, and there might be some gum and varnish and kind of nasty looking stuff in here when you take this apart, and that's normal. As gasoline sits, it starts to go bad and deteriorate, so it might not be this perfectly clean, but it's definitely there's much less pieces in that. So start with the carburetor, and then as you build up comfort, go from there. Again, I recommend you take apart stuff that isn't super precious to you, super important, so that if you don't get it back together, it's not the end of the world. Start with those small successes of taking things apart, and then that leads to being able to get stuff back together, because you start to see how stuff comes apart and how it's fitted together, and that helps you get stuff ultimately back together.
Okay, thanks.
All right, no problem. Okay, any other questions? All right, so with that, what I can do for you guys as well, like if you're doing the carburetor first, don't worry about the due dates. Like I can move the due dates for your engine disassembly back if you're going to do the carburetor activity first. I want this to work for you, so we can make those adjustments, so to speak, on the fly. So I don't want you to be worried like, oh, the engine one is due before the carburetor one. I can switch that for you, so that's not a big deal. Question, yeah.
What is a good resource for racing small engine manuals?
For racing small engine manuals. Okay, so a good source for racing engines, let's see, how can I get this? There we go. So you know how we have all this information from the Briggs Power Portal? Briggs & Stratton on their racing line, you don't even have to go through the Power Portal. They have all the technical information up right away. So this is the Briggs Racing website. If I click any of these engines, or I click support or videos, and I did add these links onto Canvas, but they have all kinds of videos and links of how to work on the engine, how to check the carburetor. Like here's their videos on setting carburetors and slides and all this type of stuff. So there's great resources there. From support, you can get the manuals for the different engines. So if I wanted the manual for a World Formula engine, it's there. But beyond that, there is some 2-stroke high performance books, but they don't necessarily tell you exactly how to work on it. So what I would recommend is if your engine is off something, whether it's a jet ski, a dirt bike, a quad or ATV, you figure out what it's off of and buy the manual from Climber or Hayes or something. Buy the manual for that particular product, and it will show you how the engine goes together. There's not any one thing necessarily that's going to tell you how to race the engine and how to set it up, and you know that's kind of the art of racing, is figuring out all that stuff. There's some stuff that can get you kind of go in the right direction, you know. But what I would say is, if you're going to race something, is try to go to where it's raced and talk to other racers and get some advice that way. And then, you know, there are some books specific to karting. Oh, maybe I got the wrong thing. Secrets of Speed. So Memo Gidley has some books that are decent. That is not what the cover of the book looks like. But anyways, it's a little hard for racing stuff in particular. I would start with the Briggs & Stratton Racing website and kind of go from there. All right? Any other questions?
Okay.
All right, everybody. Well, again, I'm sorry I took you past time. I'm going to let you go and get back to your normal lives. Thanks for hanging out this morning. And thank you for your patience getting started. All right, everybody, take care.
Thank you. You're going to post this up pretty soon?
I will get this posted up
Thank
probably
you.
tomorrow morning.
Okay.
All right?
All
All
right,
right,
thank
thanks.
you.
Thank
Bye,
you.
bye.
All right, have a good day.
You too. Bye.
Bye.